Hello everyone. In this video we will begin to examine topic 5.3 electric cells, and in particular we will look at cells in general. So up to this point we have simply assumed that the cells providing an EMF to a circuit have been ideal sources of direct current potential difference. So DC current, I should note, is in contrast to alternating current, AC current, in which the EMF is oscillating from negative to positive. So AC current sort of oscillates back and forth. We'll discuss this more in the HL topic 11. For the core material, we're still focusing on DC circuits. The second thing to note, very minor detail, is that the difference between the term cell and battery, which I have been using more or less interchangeably, is that a cell is a single source of EMF, and then a battery is multiple cells wired together in series or in parallel, depending. So the battery is a battery of cells. That's the way to describe it. So how do these things actually work? Well, a traditional electrochemical cell, okay, of the kind that you would find what we would normally call a battery, right, like a AA battery, is composed of multiple cells, and each of those cells is composed of separated ions, which ultimately provide both the EMF and the current. So via some mechanism, the ions are stored inside the cell itself and separated when that cell is fully charged, okay? Then what's happening, all right? Well, consider sort of the two ends. The traditional sort of positive end of our cell is a source of conventional current, which means that electrons are sort of flowing through the rest of the loop and then into that end. And conventional current is flowing into the negative end. But inside, what's happening, more or less, this is sort of a simplification, but more or less is that the separated ions are sort of evening out. And that evening out is what allows the electrons to flow in the rest of the circuit. So the positive ions are sort of delivering electrons and then moving over here inside the cell, and the negative ions are moving over here inside the cell. That happens slowly, and the only way for them to sort of transfer electrons is in the rest of the cell. Those of you who are chemists will deal with this in much more detail when you study voltaic or galvanic cells, but this is just the general idea. And the important thing to recognize is that inside the cell, right, this flow of ions is that current. So I've been careful to emphasize the fact that the total current outside the cell is also the current of the battery, the current inside the cell. And it just consists of the movement of these charged particles, in the same way that current outside the cell consists of the movement of charged particles. It's just that inside the cell it's ions, and outside the cell it's electrons in the wire itself. In a new cell, there's a buildup of these positive ions or cations on the right side here, and a buildup of the anions or negative ions on the left-hand side. It's important to note that as ions flow inside the cell, energy is lost as thermal energy to the surroundings in the cell. And this is the key piece or the key ingredient that we have up to this point ignored. So in our next video, we're going to shift away from discussing ideal cells or ideal sources of potential difference and move to discussing real ones, which do end up delivering energy, thermal energy, to the surroundings directly.